This video is recorded to help my students to understand big O notation. Let's first see the definition from your textbook. And your textbook says, let f and g be two functions from n to n. We can say these n are positive integers. Then f equal big OG if there are positive constants c and n0 such that for any n greater than or equal to n0, fn will less than or equal to c times gn. The notation f equal big OG is read as f is big O of g. So by this definition, we need to pay attention to several facts. First, this n0 and c are not unique. So he just say if there are positive constants c and n0. So they not say only have one. Actually, you have infinity because once you found n0 and c such that for any n greater than n0, fn less than equal to cgn, then for any number that greater than n0, any number that greater than c can be used to replace n0 and can be used to replace c. Okay? The reason is if you use a large number to replace n0, well, for the n greater than equal to that large number, those n is just a subset of the n greater than equal to this n0, right? It's more obvious if you replace c by a large number, large constant. Then, of course, for the smaller c, this is true. Then for the large c, this will be true for sure because both fn and gn are positive, right? So, another thing is the big O notation. You still need to understand give the upper bound of running time. Suppose your f and g are running time, right? F is bigger O of g means that up until a constant coefficient, f is controlled by g. That means c times gn is bigger than fn. If c and f and gn are both running time, that means the running time f is less than a constant times running time g. Or we can say f is a lot slower than the running time g up until a constant coefficient. So the next factor is if you wanted to show that f is big O of g, we only need to find one n0 and one c, which are both constant, such that for any n greater than n0, fn is less than or equal to c times gn. So you need to find this n0 and c. Let's say an example. For example, if I want you to prove Tn equals 3n squared plus 100n plus 10,000 equal big O n squared is big O of n squared. Now, how to prove that? We wanted to find some n0 and some constant c, such that for all the n greater than n0, this polynomial will less than equal to cn squared. Now, one proof is this. Now, let's just pick n0 is 1. For all the n greater than equal to 1, what constant times n squared can control this polynomial? The idea is, since n is greater than equal to 1, so n is less than n squared, right? Since n is a positive integer, so n less than n squared. 1 less than equal to 1 squared, right? 2 less than 2 squared, which is 4. 3 less than 3 squared, which is 9. Okay? So n will less than n squared. And 1 also less than or equal to n squared. So based on that, Tn equals 3n squared plus 100n plus 10,000 will less than or equal to 3n squared. Well, then 100n squared, then plus 10,000 n squared. If you add those up, is 10,103 n squared. So equivalent, say we found n0 is 1, and the constant c equal 10,103, such that for all the n greater than equal to 1, Tn will less than equal to this c times n squared. Therefore, by definition, Tn is, here I mistype, I should say Tn is big O of n squared. Okay? Now, we can prove in a different way. We can find a different n0 and a different c. So for example, here, I can do this. Let n0 equal 100. So I want to say, show that for all the n greater than equal to 100, this polynomial will less than equal to some constant times n squared. So if n greater than equal to 100, what can you say? 100n, and n is greater than 100. So 100 is less than n. 100n is less than n squared, right? Less than or equal to n squared. 100,000, actually we only have, we start at 100,000 is 10,000. 10,000 is 100 squared. Since n greater than 100, so 10,000 is less than n squared. Therefore, those polynomial were less than or equal to 3n squared plus n squared plus n squared, which is 5n squared. Okay, so we found n0 equal 100. Constant c equal 5, such that for all the n greater than equal to n0, Tn is less than equal to Cn squared. Therefore, by definition, Tn is bigger O of n squared. So notice for the same problem, we use two different ways to prove it is bigger O of n squared for this polynomial. But in these two different ways, we have two different n0 and c. You might be able to guess that means if n0 is smaller than c, it should be larger, right? Yeah, that's technically is true. Okay, so let's see some fact. The fact, if Tn is a polynomial of order k, degree k, so equivalency Tn is ak times n to the k power plus ak minus 1 times n to the k minus 1 power plus up to a constant a0, where ak not equal 0. Okay? In this case, what can we say? We can say Tn is bigger O of n to the k power, which because as n get larger and larger, n to the k power will dominate all the rest of the terms. Okay? So now we can say for the polynomial, its bigger O notation is just is bigger O of the highest degree term. So for if it's a 3 degree, then it's bigger O n to the third power. If it's a quadratic function, it will be bigger O n to the square. Okay. Now let's say some other facts. When n is large enough, we always have those inequalities. 2 to the n power is always greater than or equal to n to the any power. Like n to the 10 power, n to the 3 power, n to the 3 power, of course, greater than or equal to n to the square. N to the square is greater than or equal to n times log n. N times log n is greater than n, and n is greater than or equal to log n, and the log n is greater or equal to some constant. So, based on that fact, we can say every time if we want to estimate find the big O notation of a given function, we always find the largest term. Okay, for example, n squared plus 3n times log n plus 1000n. Now, based on the above inequality, we know n squared is the largest term here. So this whole thing will equal bigger O n squared. Now the second example, 3n log times log n plus 1000n. In this case, n multiplied log n is greater than n if n is bigger enough. So if n is large enough, okay? So if n is big enough, this will be n multiplied log n is always greater than or equal to n. So in this case, we only pick the large term. So this will equal is bigger O of n times log n. Now, next example, if you have 10 log n plus 10,000, right? Since log n is always greater than constant 1, okay? So in this case, large term is log n. So this is bigger O of log n. Okay? If you have any questions, please give me an email.